Drunken forests, also known as tilted or wandering forests, are a striking ecological phenomenon. These forests are characterized by trees leaning at odd angles, creating a surreal and chaotic landscape. This unusual tilting is primarily caused by the thawing of permafrost, a layer of frozen soil found in Arctic and subarctic regions. As the permafrost thaws due to rising global temperatures, the ground becomes unstable. The once solid foundation beneath the trees starts to give way, causing the trees to tilt and lean. Climate change accelerates this process, leading to more pronounced and widespread tilting. The result is a forest that appears almost otherworldly, with trees leaning in all directions. This phenomenon is not just a visual oddity, it is a clear signal of significant environmental changes. Drunken forests serve as a stark reminder of the impacts of climate change on our planet. They highlight the delicate balance of ecosystems and how easily it can be disrupted. Permafrost, which acts as a foundation for these ecosystems, is crucial for maintaining stability. When permafrost is stable, it supports plant growth and provides a solid base for trees. However, with rising global temperatures, this stability is compromised. The thawing permafrost leads to uneven ground, causing trees to lose their anchorage. As temperatures continue to rise, the problem worsens, leading to more extensive thawing. The once frozen ground becomes waterlogged and soft, further destabilizing the trees. This uneven subsidence creates a chaotic landscape where trees tilt in random directions. In severe cases, the soil's ability to support tree roots is entirely compromised. This leads to tree death and further disruption of the ecosystem. The death of trees can have cascading effects on the entire forest ecosystem. The loss of tree cover can lead to soil erosion and further destabilization. This creates a vicious cycle where the ecosystem continues to degrade. Drunken forests are more than just a visual phenomenon, they are indicators of severe ecological shifts. When permafrost thaws, it releases stored greenhouse gases like carbon dioxide and methane. These gases exacerbate global warming, creating a feedback loop that accelerates climate change. Trees in these regions, which once acted as carbon sinks, now struggle to survive. The death of these trees reduces their ability to offset carbon emissions. The thawing ground also alters the hydrology of the region, turning areas into wetlands. This shift in landscape affects the balance of plant and animal species. The destabilization of ecosystems can have cascading effects on local biodiversity. Climate change is the main driver behind the expansion of drunken forests. The Arctic is warming at nearly 4 times the global average, accelerating permafrost degradation. This transformation affects not only forests but also infrastructure and communities reliant on stable permafrost. Observations and researchers are closely monitoring drunken forests as indicators of permafrost health and climate change impacts. Technological advancements such as satellite imagery and on-ground sensors allow scientists to track the progression of permafrost thaw. Mitigating these changes involves addressing the root cause, reducing greenhouse gas emissions globally. Locally, efforts focus on adapting infrastructure and conserving vulnerable ecosystems. Drunken forests are a stark reminder of the interconnectedness of global systems. While they may appear as an oddity of nature, they signify the urgency of addressing climate change. Their tilted trees tell a story of imbalance, a cautionary tale about the fragility of Earth's ecosystems in the face of human-induced warming.